Today I'm making a video demonstrating the various effects of two very common industrial acids, the nitric acid and sulfuric acid, but mostly we're focusing on the nitric acid, on various materials here demonstrated on the tray. I'm going to go and review the different items first before we get started so you know what we're dealing with. Now this little ribbon here is very commonly seen sealant tape. Usually we call it Teflon, but it's really PTFE, which is polytetrafluoroethylene. And unlike most plastics, it actually features a polymer made without hydrogen. Instead, you're using a fluorine or fluoride. So because of the fluoride, I believe this is the reason why it's so resistant to most acids, where like nitric acid, for example, will start to deteriorate pretty much any plastic if it's got a high enough concentration. There's nothing that can really resist it except for this and glass. Now, hydrofluoric acid, for example, it can eat glass regardless, and actually it needs to go the other way. It needs a plastic container in high concentrations. But that's not the point. We're gonna show you what the metals here is. We have a cube of refined copper, silver that I've actually made from old silver coins, melted down into this lump here, and we have a little bead of gold that's also made from recycled material, specifically from computer components. And I've made this chemically pure through a process where I've actually not only separated the gold from the base metals, I was able to precipitate the gold separately from the base metals and then melt it down into this little bead you see here. And I also had, from one of my orders, somebody sent me a piece of crystalline silicon, and I'm not really sure, I've never tested this before, so I'm not sure how it will react, but to my knowledge this is actually very resistant to acids, in the crystalline form especially. And the tray itself is made of aluminum, but because we're not testing hydrochloric acid, which is very aggressive against aluminum, even if it's got the aluminum oxide skin, it's still not safe from hydrochloric acid, or as you would find in the store, muriatic acid. We have PLA, which is made from a little old 3D print I made a long time ago, which is polylactic acid. Typically this is made from plant matter such as sugar or corn starches and such, and then it's reduced from all of its moisture and other agents. We have styrofoam or expanded polystyrene, and this for the demonstration is going to be, I've done this before, it looks very, very aggressive, and how the nitric acid eats through this. And that's, I wanted to point out, is because most likely it's because it's 95 to 98% air overall, so it actually has to eat through very little plastic material just to expose the air underneath, and it'll dig into this, kind of like you see from the scenes of Alien going through metal with the alien blood just burning through everything. And then you have the nitrile gloves that you commonly see as a substitute for latex gloves. Now, typically speaking, this is good for handling chemicals and such, but I wanted to use this specifically for a demonstration to show you that this is actually potentially hazardous to use with nitric acid, especially in higher concentrations, which is what I'm going to demonstrate. And I'm wearing them now specifically because I'm going to be handling a different kind of acid, which is sulfuric acid. And sulfuric acid is very, very aggressive on the skin, and I would rather risk getting nitric acid on my glove and having a terrible, basically have a fit just trying to get the glove off really quickly before I douse it in water or anything, than having to deal with sulfuric acid getting directly on my skin. And at the last bit, there's a bit of paper, and this is mostly to demonstrate the aggressiveness of sulfuric acid. And we have two pieces of fingernail, and I know that's gross for some people, but I wanted to demonstrate fingernails as a substitute for skin and how these acids react to it. So one's going to be tested for nitric acid separately from the sulfuric acid. And here are the bottles. This right here is the sulfuric acid, and I got this at a grade of about 98% purity. which is actually very thick. It's almost like a light syrup. And we have nitric acid that I've made at home, and I've done a density measuring to basically figure out that it's around roughly 85 to 90% pure based on its weight and volume. And I'm going to take this incredibly strong nitric acid, because typically speaking, when you buy nitric acid, it's not so strong that it will eat through the bottles that they're being delivered through, and so they usually dilute it to about 70% or less. And the reason, because like once you go past 70% or more, roughly speaking, I don't know if that's really the limit, but you get a substance called fuming nitric acid, in which you can actually get fumes from it reacting to the air itself, creating nitrogen dioxide. Now let the demonstration begin. And first of all, you can actually see the smoke coming off of it, which goes back to what I was saying about fuming part of it. And I can actually smell it from here, and I'm very much far away from it. And if you put it on the copper, the thing is with nitric acid is that it typically reacts with copper very well. It's one of the few acids that do. But there's an interesting little property where if it's so concentrated, it'll create something called passivation, which is where it actually reacts so quickly to the surface, it creates a skin that pacifies it from the rest of the acid, meaning the acid can't actually penetrate through that skin to eat away at any more of the copper underneath. And so it actually would become more vigorous if you add water to this, so that it can actually peel away at the pacified skin to get underneath where the acid can start going to town for the rest of the copper. See, next up we have silver. And one of the ways to test if something is actually genuinely made of silver is to use nitric acid, because again, it's one of those metals that does not really typically react to a whole lot of different acids. And based on the color, you can normally tell whether or not you've gotten a fake piece of silver or such, or something that's just plated in silver. We have gold. And I really kind of doused it a lot, but it really doesn't matter, because gold does not typically react at all to nitric acid. You see, it would only kind of react to it if it was mixed with hydrochloric acid to create an acid known as aqua regia. And it's this combination that basically allows it to cycle between the two acids to oxidize, then break apart, and oxidize and break apart. And the gold will actually cling to the chlorine atoms and the hydrochloric acid, and the nitric acid would basically just keep eating it until it gets completely neutralized. Now I'm going to do some silicon. And unsurprisingly, I don't really see any kind of vigorous reaction whatsoever. Now, I've never done PLA. We're about to see what it does now. But typically speaking, in my experience, nitric acid in concentrated doses is usually really aggressive. And I can actually poke it and feel the plastic getting softer. I mean, there's definitely some reaction going on, but it's not like a lot of smoke or anything happening. It's not a very telling reaction. But here's where it gets really interesting, is when you put it over polystyrene. Yeah, you can hear that hiss and that sizzle from like the acid itself actually boiling because it's getting so hot from the reaction. And it just eats a cavity into the polystyrene, and getting a lot of like nitrogen dioxide fumes I can smell from here. But this never fails to impress me, like just how strong this is. Now for the Nitrile Glove, I'm actually going to move this. The Nitrile Glove, I want to, here we go, already got a few drops, and see? Catches fire. And it's for this reason that's actually a bad idea to wear gloves made of nitrile or basically almost any plastic whatsoever, because a similar reaction will occur if you get this on your gloves as you're working with it. And on top of that, the gloves are super thin, so they actually have an easier chance to erupt in flames than if it was much thicker. That's why some lab gloves, even if they're not entirely resistant to the materials, they're actually made super thick so that they're not likely to ignite in the first place, but they'll still react on the surface. Now, like when I put down my little pipette, it's got directly on some of the aluminum, and as you can see, it's not reacting, like not one bit. Put some right here. And as you can see, like it immediately changes the color of the white paper right away because it's oxidizing it and reacting to it. Now here's the part that's really interesting, the Teflon. And one of the things that's interesting about Teflon is that you can't really get adhesives on it, you can't really get acids to react to it, and it just, nothing happens. And that's what's really reliable about it as far as using it for sealants. Now, one of the things I was always concerned about is that when you buy store grade anything that's advertised as copper or advertised as one element or one kind of plastic or another, that they're really not purely that one thing, but they're really a combination of other things. Like kind of like how you get aluminum pipes, or not aluminum, but copper pipes that are alloys of several metals. They're just mostly composed of copper, which is why I specifically wanted to take a copper block that's made of refined copper for this demonstration. Now, what's happening here is like the pipettes can't seem to hold the pressure of the nitric acid, and so it's just dripping on its own. So I'm gonna have to put this to the side. But then again, I also really like to demonstrate it on the polystyrene because it's just so fun to just see that crazy fast and active reaction. But the fumes very obviously are not very pleasant. And last, I want to show what it does to the keratin on your nail or your skin. And if you notice, it's not really erupting into flames or anything. It doesn't even seem to dissolve the nail that much. And you may be thinking because the nail is like something else or something super thick. Well, nitric acid immediately kind of responds to the keratin on the surface of your skin, and it will change it to like this bright yellow to deep orange color. That is before it starts eating a little bit too much, and then it starts going through your skin directly. Now, if I take this sulfuric acid dropper right here, typically you're not going to get any kind of reaction, because unlike nitric acid, sulfuric acid doesn't really do anything to most things, unless they're like organic matter. Like say for instance, we're going to put it on this piece of paper. And a piece of fingernail. And Teflon. And the glove. But I don't expect a reaction because I specifically wore this because I knew there wouldn't be a reaction. See, it turns